I mentioned that with test-driven development, you need to create the tests first. But still, even if you're creating the tests first, you still need a program to be able to point to that you're going to be testing. It's as though you're building a console app and you need to call a method. If you're just trying to make sure that the app compiles, you still need to put in an empty method that you're going to call. So that's pretty much what we're doing here. So here's how we will start. First thing is here we go. We'll generate a new solution that includes a class library project and name it Find Price Ride Along. So if you will create a new solution or open up Visual Studio, and then we'll say create new project. And then instead of creating a console app, come here and select C# in these drop downs and test, just C# in this drop down and all project types. And then up here, type in class library, and you'll see that there are several things that have the words class library in them. The one we're looking for is class library.NET Framework. Don't pick .NET Core, don't pick .NET Standard, make sure to pick .NET Framework. So we'll click it and hit Next. And then here we'll just call it Find Price Ride Along. Hit Create. And there we go. So next, we're going to rename the generated class to Find Price class. And when I say the generated class, if you take a look here, you'll see public class, class 1. That's the one we want to rename. So I'll actually come over here and do a rename on the file itself. We'll call it Find Price Class. And then Visual Studio allows me to rename all references to that piece of code. So when I do that, you'll find that up here the name changes as well as the name of the file. Plus there are a bunch of internal elements that Visual Studio uses to keep track of where everything is and how everything hangs together. So it's all there too. Okay, next thing. We're going to create a method called Find Price per Anvil that has the signature you see there. So it takes an integer, it finds the price, and returns the price as decimal. And what we'll do is just return the value 999 from that method. Later on, we're going to make it actually work, but for now, we just want to make sure that it can be called and that our tests will be able to compile. So that's what we're going to do. So let's come over here and we'll add a method called public static decimal find price per anvil that takes an integer called quantity. And then as the method body, we'll just say return 999. So no matter what quantity comes in, we're just going to return the value 999. Okay, so why are we doing this? Well, in test-driven development, you have to build a shell for the method under test whenever you're creating your tests. Then you create the tests, and they're always going to fail, because if you're expecting to get 80 back when you put in a quantity of 1, well, you're going to get 999 because that's the way we wrote the code so far. But that's okay, because that's in test-driven development. You'll understand this as we go on. you want to start with the test failing, and then you adjust the code so that the tests pass. When the tests fail at the beginning, it's called being in the red phase. And then by adding the code that makes the test pass, you move to the green phase. So that's what we're going to demonstrate here. We're going to start in the red phase by building tests that fail. Then in the green phase, we'll get the test to pass. And then we're not actually going to do much in the way of refactoring, but a lot of times after you've gotten your test to pass, you want to do some rework. We aren't going to do that today. But this is the cycle in a real test-driven development process. Start with tests that fail, make them pass, and then tune them up and make sure they're efficient and effective. Okay, so now we've got the software under test ready to go. Now we're going to initialize the unit test. So here's how that works. The first thing we're going to do is add a unit test project to the solution. So far in our experience with Visual Studio, we've always only had one project per solution, and it's always been a console app. But here we're going to add a second project to our solution. So let's go ahead and do that. Up here in the solution, on the solution, we'll right-click it, come down here to add, and say add new project. Then we want to find a project of type test, so we can type test here. And what we're looking for is the option that says unit test project .NET Framework. So don't pick any of these others. Make sure you pick this one. So click on it, and then we'll hit next. We're not there yet. Then we'll just keep this name, Unit Test Project 1. And there we go. We've got this this unit test project that has these interesting elements you've not seen before. These are called attributes. That's when you see something in square brackets like that that stands apart from the other code, those are attributes. And these are attributes that the Visual Studio test framework recognizes, and it makes it understand that, oh, well, a test class above a class declaration means, this class is going to hold some tests. And a test method above a method declaration tells Visual Studio, aha, this method is going to hold a test. So that's what's happening there. If we look at the references in the unit test project, you'll see that there are some things here that are specific to testing. So there's the test framework, there are some test framework extensions. And we haven't really looked at references before, but they're pretty important. This reference here, the one to the system assembly, that's the one that allows you to use such elements as readline and random and all the math stuff, math.pow, math.round. So these references are critical elements of any program you write. But here, because we built a unit test project, Visual Studio gave us some special assembly references that will enable you to invoke unit tests.